Hello! In this video, we're going to be learning about arrays. Arrays are a powerful data type for numerical operations and data storage from the Numpy module. Arrays are indexed the same as lists, and lists can be used to create arrays. Arrays can be of any dimension. .shape and .size are useful to keep track of array dimensions. .ravel flattens arrays to a single dimension. Unlike lists, arrays can only be a single data type. Conveniently, mathematical operations can be performed on an entire array without a loop. There are many mathematical and statistical NumPy functions like minimum, maximum, mean, and standard deviation that can be performed on arrays, and in some circumstances, lists as well, using an np.function format. Blank arrays of zeros and ones can be created, and this is useful for creating templates for data analysis. So let's get started. In this video, we're going to be using a set of data. This is taken from the NOAA. It's in Fahrenheit, the maximum, average, and minimum temperatures in the month of January for the first 7 days, the 1st, 2nd, 3rd, 4th, 5th, 6th, and 7th days of January from 2018 and 2019. And these values and data are provided in the notebook and in the description of the YouTube video. So you can just press Shift-Enter, and these are all lists. So each of these is a list object that contains all of this data. And as you'll see, there are many similarities between lists and arrays. So let's first start by creating a nested list of lists. And we will call this the overall list. And remember that we use square brackets. And we can put in January 18th, the max, January 2018 average, January 2018 minimum. And that's one list, but we can create a list of lists. And we do that by adding a second square brackets, and we can put a comma and add our second set of lists. So we can do January of 2019 max, January of 2019 average, and January of 2019 min. So there we go. We have a list of lists, and we can press Shift Enter, and we have our overall list. But let's create an array now. So we can import NumPy. NumPy, most of its popularity and its power comes from arrays. So to use the arrays, you have to import NumPy. So we import the module, and we import it with an alias np. We press Shift Enter, and let's create our first array. And so we give our array a name, and we'll call it overall array. And to create an array, we use the np.array function with the smooth brackets. And within this function, we can put a list or a list of lists, and it will convert it into array. And so in this sense, there are many similarities between lists and arrays, especially in their structure, that you can use a list to create an array with the square brackets, and they can be of multiple dimensions. So we press Shift Enter, and then we have our overall array. So even though these are very similar, lists and arrays, you have to keep them separate because there are certain things you can do with lists and not arrays, and a lot of things you can do with arrays but not lists. So we can always press Type, and we see that our overall list is a list, and we see that our overall array is a NumPy in-dimensional array. So we've created a list and array. And for all intents and purposes, as you've seen, they have a very similar structure, and they have the exact same data. So let's actually just look at the array that we just created. And so if we press Shift Enter, we can see that it's very structured, and it has a nested order. We have the data from January 2018, the data from January 2019, and in Fahrenheit, we have the max, the average, and the minimum for each of these years for the 1st, 2nd, 3rd, 4th, 5th, 6th, and 7th days of January. This is a very typical type of array. It can have any number of dimensions. The numbers of rows and columns and higher order structure is regular. That is, there's the same number for each of the features. And it's nested and hierarchical. If ever, arrays can be quite big. They're used for data storage often. If ever you need to know the structure of what you're dealing with, .shape and .size are two very useful functions. So let's look at the shape of our overall array. And you can see that it's a three-dimensional array. The first dimension has two different objects, the 2018 data and the 2019 data. Each of these two objects has three different values. They have a max, an average, and a min temperature. And then within each of those, that dimension of the array, you have 7 more values. So this is a three-dimensional array where the dimensions are of values 2, 3, and 7. And this is very useful information to know. You can also just get the size of the array that you're looking at, which is just a measure of how big is it. So 2 times 3 times 7, we have 42 different values in this array. If you wanted to, you can also use something called ravel to flatten your array. So let's take our array and use the ravel function, and we'll create a new array called unraveled. So we've created unraveled, and we can take a look at unraveled, and it is still an array, but it's just the 42 values straight. So we have these values, and then we go to these next levels, and instead of having all the hierarchical order and different dimensions, it just in order took all the numbers and created a single dimension. And we can look at the shape of unraveled now, and you can see that we just have one dimension of 42 values. So there's a lot that you can do with, you can create an array of any number of dimensions, of any type of structure. You can also flatten that structure and just get straight numbers back. But let's go back to our overall array. And let's look at indexing now. So indexing, you'll be very familiar with already. It's just like lists. And if you have a multi-dimensional array, it's just like a list of lists. So if we just index using a single number, let's just take the first element of the array. The first dimension is 2, and we take the first element, and that's just the 2018 data. So it returns the full array of January 2018 data. We could also look at the 2019 data in this way, looking at the second element, and then we would have the 2019 data. We could also index from multiple levels. So let's say that we wanted to look at the first year, and that we wanted to look at the maximum temperatures, which is the first element of the 2019 data. And then let's say we wanted to look at the third day. So this is January 1st, 2nd, and 3rd of 2019, and this is the third day. So we should get 38 back, and we do. So using multiple square brackets, you can very precisely index to particular values. Unlike lists, arrays can only be of a single data type, and you can specify what that data type is. And the reason it's important that it can only be one data type is because, as you'll see, we can perform mathematical operations, but if we have all sorts of different data types, it can be very confusing for Python to decide what to do with all the numbers in an array. So it has to be the same thing, although you can specify what that is. So let's create a new array, and we will call it floats. Using the np.array function, we will take the array we already have, and we're going to force it using this dtype argument to be float. So if we execute that, and then we look at the new array that we've created, we can see that they are all floats. And we can do this with integers. And we can say np.array overall array dtype equals integer. And so we create, typo here. There we go. And if we look at our new integers array, you can see we have now only integers. And you can even do this with strings. So we say strings is our new array from overall, from overall array, and we say dtype equals string. So then we have our string array, and we look at strings. And there we go. All our numbers have been converted to strings. So you can create an array of any type of data type that you want, except that all the elements of your array have to be the same type. So let's go back to our original array. And the real power of these arrays is that, unlike a list, you can perform mathematical operations on every single element in the array. And this is really convenient because with a list, you have to go through each element one by one in a for loop. But with an array, you can just do the math on the array. So these are all Fahrenheit values. Let's convert them into Celsius. So we can just take our array and we subtract 32 from it. We multiply this by 5/9. And there we go. The entire array has been immediately converted into Celsius. If we did this exact same thing with overall list, we get an error. You can multiply lists or add them. That will basically just concatenate and repeat the list twice, or however multiples or additions that you want to do. But you can't be subtracting a number and dividing and things like that. So this is one of the real powerful aspects of an array, is partly because you forced it to all be a particular data type. And even within multiple dimensions, you can just perform the mathematical operation, just calling the overall array, and it will perform the operation on the entire array. So again, let's go back to our original array. And on top of just doing mathematical operations on the entire array, you can do functions that consider all the numbers in the array. So let's say we wanted the average from the 2018 data, taking the average numbers, temperatures for the week. We want to take the mean of the averages for the 2018 data. So we would first index that we wanted the 2018 data, and we want the second element of it, which is the averages. And then we can just use a function, .mean. And if we do that, what happens is that we take the average of this row right here. We just very simply taking the average of the means for the 2018 data. We could do a variety of other different functions as well. If we wanted to sum up those numbers, we can just use sum, and it takes the overall sum. We can look for the minimum value, and the minimum value is -1, as we can see here. And we can also take the maximum value, and if we take the maximum value, we can see that that is 18. We can do other useful things, like we can take the standard deviation of the means of that week as well. And there we go. We have the standard deviation. You cannot do this with a list, but Numpy is very convenient that a lot of times you can use these functions. It's a different format. You say np.mean, and then within the parentheses, you put a list. And if you do that, you see we get 7.42, which is exactly what that is. So it's very convenient that if you're not working with arrays, rather than convert an array to a list, you can just call this function and put a list within it, and it will do the function. So I hope you see how convenient NumPy and especially the array data type is. There's all sorts of useful functions. Let's say we wanted to sort these values. We can create a new array using the np sort function, and we say overall array sort, and then we can look at what the sorted array looks like. And there you go. You can see that for each of the elements in the array, where we had our original data, instead the data now is arranged and sorted from minimum to maximum values. So there's a lot of convenient functions where you can evaluate the array as a whole, which is something you really can't do with a list, because you usually have to go through list comprehension of using a for loop or some other method of evaluating each element of a list one by one. With arrays, you can just do the whole thing. Because of their multidimensionality and because of the ease of performing numerical operations on the whole array, you'll often find yourself wanting to create an empty array, or not necessarily empty, but filled with blank data that's either zeros or ones. And you just are doing this to create an empty array that has the right dimensions, but then you can fill it up with the right data. So the zeros function will create an array of whatever dimensions that you specify in their size. So we're creating an array of the same size of our overall array with two different elements, then 3 in each and 7 in each of those. If we wanted to, we basically created a blank slate here. We could fill in values that we wanted to in whatever position that we needed to. Zeros and ones are very convenient because they're kind of default values. So there's also a NumPy ones function that can create the same data set with ones. And there's something also too where you can almost create copies of data sets. They're called zeros like. So this is using np zeros for an array like the one we already have. So it will just copy the dimensions of the array you have and put in either zeros, or it will put in ones. So that's a little bit about NumPy and the most powerful aspect of NumPy, which is arrays. And you see that arrays are a powerful data type because you can perform numerical operations on them, and they're very convenient for data storage because of their dimensionality. Arrays are a lot like lists because they're indexed the same, and lists can even be used to create arrays. Arrays can be of any dimension, and dot shape and dot size are useful ways to keep track of array dimensions. The ravel function can flatten an array to a single dimension, which might be useful in some circumstances. Unlike lists, arrays can only be a single data type, and conveniently, mathematical operations can be performed on the entire array without evaluating each element like a loop. And there's many mathematical and statistical NumPy functions like minimum, maximum, mean, standard deviation, and you can even perform a lot of these functions on lists themselves if you call np.function and put the list in the parentheses. And you'll often find yourself later using arrays to store data, and you'll need specific dimensions, and so you can create quote-unquote blank arrays using zeros and ones, which can subsequently be filled with your data. So that's all for this lesson. Thanks for listening.